Hi everyone. Today we are going to learn about how to calculate topographic wetness index, and for that the general formula is logarithmic of the ratio of flow accumulation to the tan of slope in radians. So for that there are various steps that you have to follow, and the first input is digital elevation model, and I prefer to work with projected coordinate system. So when you go and check on the properties and go to the source and check on this special reference, you can find which coordinate system is there. For now, I have WGS 9084 UTM zone 10N, so I will be working on this projection system. So you can always convert based on whatever projection system that you required. So for the first step, what I'm going to do is I'm going to the tools, go to analysis on your toolbars and click on tools. So yeah, I've already opened this sections, but I will show you. If you go to toolboxes, sorry, if you go to toolboxes and under the spatial analyst tool, you will find hydrology, and there are lots of tools that you can use to calculate this topographic wetness index. So before calculating topographic wetness index, as you are already familiar, that the formula is log of ratio of flow accumulation and slope. So we need to calculate flow accumulation and slope. For that, when we are using any DEM, the first step that you have to do is go and fill the DEM. So we are going to input this digital elevation model and calculate this field DEM. I just gave it a name as it is required and the input, and you just go and click on run. Once it is calculated, then you will the next step is to calculate the flow direction, because to calculate a flow accumulation we will require flow direction, right? So yeah, let me just wait for this computation to be completed. Once it is completed, then yeah, it is completed, then we are going to calculate flow direction. You can just find flow direction over here. Okay, so you go here, you provide the input as field DEM. You can rename as it is, as it's required based on your requirement, and to select the flow direction type at D8. You can always select whatever you require, but you have to be consistent on further step as well. So once you provided all these inputs, you can go and hit the run. Great. So let's just wait for a while to complete this computation. Okay, we have this output. So the next step, let's go to next step, and the next step is calculating the flow accumulation. You go to the flow accumulation tool, select the flow direction, see input flow direction raster is required, then name your flow accumulation as you want to set, and output data type, I always prefer to go with integer, because it is just a sum of number of cells into the specific cell. So it will be like 1, 2, or 4, and any number based on how many pixel will contribute to the specific pixel. So, and after that you have to select this method that you used for computing this flow direction, right? So we used D8, and just go and hit the run, and it will start computing, and you will get a flow accumulation. The flow accumulation is simply the accumulation of uh, uh, a direction from which the, for example, if water is flowing from uphill to the downhill, then at one specific cell, or what pixel, then how many pixel are contributing to that specific pixel, right? So that is how the flow accumulation is understood. And once you have this flow accumulation, then another step is to calculate the what slope. Okay, so to calculate the slope, first I will calculate the slope in degree, and we need to convert that slope in degree to the radian. I'll show you how to do that. Let's do it one by one. Okay, I think it is almost done here. Yeah, okay. So this is the flow accumulation. I will just turn it off for the flow direction. if you zoom into uh, and check the value in flow accumulation, see how much number is there. This is the number of contributing cell to this specific shell. Okay, so yeah, this is flow accumulation. Once you have that, the next step is to calculate the slope. For that, I will just go and search for the slope. You can find it under the special analyst tool, but I'm just going and searching and click on the slope, and I will be providing the field dm for this one, because slope is calculated based on the digital elevation model. And if you want to rename it, I will just rename it as slope degree, because I'm calculating based on degree, and I will be using the method planner, right? So all as it is seen over here, and you can just go and click the run, and you'll find the output of slope. Okay, the slope is here, but the slope is in degree, so I want to convert this into sorry, what a radian. For that, you have to go to a raster calculator under this special analyst tool, and what you can do is you can select this slope and multiply this with uh, 0.017453. Okay, once you provide this information, you go and name your slope as, I will be writing as slope red. Okay, so just to understand that it is in the radian. So go and hit the run and wait for a while. It will give you the result. Okay, so we have like slope in radians, and yeah, that's all. Now the final step, that is to calculate the what is that, flow accumulation divided by, and so on, so on. So okay, so the next step is to calculate the topographic wetness index, and based on the formula we know, what we need is, the first thing is logarithmic, that is ln. Okay, so we'll use this ln. So and we need a ratio of flow accumulation. Okay, and we have to divide this with what, slope in radian. So yeah, this is the formula. Okay, so you have to be very careful. It should be in oh sorry, for the tan over here, flow accumulation divided by tan of slope radian. Okay, so let's not miss that. Where is tan? Okay, there is tan of slope in radian. So yeah, once you provide this information, you can rename your file, and I'm giving it as short form of topographic wetness index as TWI. Then yeah, the users go and hit the run, and it will take a little bit of time. And let's just have a look by changing the symbology as well, like where the topographic index is coming higher, and where the topographic index is coming lower. So for the easy way, I just click in this symbology, so it will directly take me to the symbology. I will just go and select classify, so that I can classify a number of classes to see how much difference is there. Okay, so in plain area, the topography index are not calculated, especially yeah, if there is no change. So you can change your color scheme. Okay, for now I will just use this green to red. And if you go and zoom in, the red area are showing that these red portions, red cells, are telling that the topographic wetness index is higher in these red shells. Okay, so if you check with some of the nearby area of a stream network, you will find that it will be white. Topographic wetness index will be higher. Okay, so yeah, this is how you can compute your topographic wetness index. And yeah, thank you so much for watching till now.